Okay, part one. The first thing about these server chassis is you have to understand how they come to you at the beginning. Of course, they'll have discs of different varieties and shapes and sizes. Of course, the rebranded screen shield of the actual front end that's been silk screened. And of course, the heart. The heart of the environment, of course, is the actual logic arrays that are all plugged into the baseline motherboard. And in this case, you have two stack series 12 processors, which is a total of 24 series on processors, and that's multi-core and threaded included, as well as your RAID interface controller, which is sitting right here, your back-end chassis RAIDs, which contain and house over here on the back a series of hard drives, usually referred to as the boot drives, but they're hidden in the back, your dual power supplies, your interface I/O, and of course your insert slots for your PCIe series connections. And of course, way over there, which is something we don't use, is the remote management resource tool on this particular plastic. You can use it though. It is feasible to do, but usually not highly recommended. Now this particular motherboard goes into what we call a bias static state. A bias static state basically is where it initiates a PROM check and it fails, telling me that the motherboard itself is a problem. Not necessarily the processors or the RAM or any of the localized devices, because I've already removed all of those out of the equation so that I could specifically work only with the motherboard, and the motherboard failed. So what do I have in play for it? Well, that's easy. Over here, a new series a DX720 series motherboard, which will replace the one that we see over here currently. So with that being said, a couple of things to touch base on. One, have a good workbench like you see here that is well grounded so that you're always constantly dissipating static electricity charges. And if you do it localized, the base metal and the system itself will allow you to completely dissipate any static discharges, which means you won't run the risk of frying any of the electronics you see here on this big giant workbench. So with that being said, now we can actually interact, touch, and work with these things. But don't do this if you don't have a static shield strip wrapped around your wrist, or you've got a workbench that's actually completely grounded so static can never build up on the board. As you notice here, this motherboard deals with components. This large piece of material here in the middle is the motherboard. You have your DIMM sockets here for your ECC registered memory. You have your RAID controller modules like this and like over here. You have your disk array modules, which are standing on top of the power supply, dual power supply modules, which is located down into this area here. You also have the I/O stent area, which is basically this cartridge here, this cartridge receiver here. You see the bus slots there, which allow you to put NICs and other types of interfaces on board, both in low, small form factor and or full size form factor. This is for adaptive components and so on, but you also notice that you have special power assists on these, and that's what makes the DX720 platform such a nice platform. The 720 isn't bad either. It really isn't. But when you look in here and you see how you're working with this, as in your 4-quad NIC card, which in this case it's a 1 gig NIC card versus a 10 gig, versus the normal airflow that what you see here, thanks to these fans, and of course your SCSI bus interface, or correction, not SCSI bus. It is a type of SCSI bus, but it's actually a SAS bus or a dual line bus, which is here, and of course back here as well. So these connectors represent those interfaces, as you can see, and they allow you to be able to connect different types of devices that are either SATA, SAS, or SSD. And of course, as you can see, this particular design can do quite a few disks. So the challenge with this machine, when you first get it from, let's say, eBay, or from a company or surplus, is that this motherboard is actually been firmware coded, and that's important because you have to re-firmware it with the standard Dell 720 BIOS so that you can unlock it from the Google state that it's in. If it is in that state, it's going to be a real pain. You can do it, by the way. You can run with the pre-existing BIOS on board from Google, but it's better that you don't. You get yourself off the BIOS by following a couple of reference sites out there that talk about nothing but dysfunctionalizing the Google BIOS state. And that is done by these little tiny chips here, these little jumper chips. And you pull them off and you move them over in accordance to the procedure to clear the CMOS so that you can reload a clean version that is not OEM'd via by Google. So this is the introduction of this machine. For those who are interested in seeing it dismantled, go to part 2. And if you want to see a new motherboard that is, as we've said, is from Dell, this motherboard will not carry the characteristics of Google. It will be a Dell baseline. And this one doesn't have the bus issues that the other one has. So it will be used to replace the core motherboard in here and transport all of the subcomponents that are out here that need to be pulled out. Also, by the way, if you don't notice this, way down right here, believe it or not, that is a USB output. It's just a micro level firmware or a load base bootloader, or it can be secure data access and so on. But it's kind of hard to see it unless you get in there real tight to take a look at it. But you'll find there's quite a bit that you can do with this motherboard. It is not a simple processor board. This is a data mover. It can be a part of an HPC cluster. It can do just a lot of functional roles, better and more robust than most other types of servers out there. So if you can ever get your hands on one of these for a few $100s, do it, please, because it's worth it. This is going to conclude our introduction of part 1. I'll let you go, and we'll see you in a bit.